In 2017, astronomers detected something moving through our solar system unlike anything ever seen before, an object so strange that some scientists seriously wondered if it could be artificial. Oumuamua was discovered on October 19, 2017, by astronomers using the Pan-STARRS telescope in Hawaii. Its name means scout or messenger in Hawaiian, chosen because it was the first known object to visit us from another star. Astronomers quickly calculated its trajectory, discovering it was moving far too fast to be gravitationally bound to our Sun. This confirmed Oumuamua had originated from outside our solar system, making it the first confirmed interstellar object ever observed. The object was moving at approximately 87,000 kilometers per hour relative to the Sun when discovered. Astronomers estimate Oumuamua had been traveling through interstellar space for possibly hundreds of millions of years before arrival. Unfortunately, Oumuamua was only discovered after it had already passed its closest approach to the Sun. This meant astronomers had only a brief window of several weeks to study the object before it became too faint to observe. Despite this limited time, telescopes worldwide raced to gather as much data as possible about the unprecedented visitor. Oumuamua's brightness varied dramatically as it tumbled, changing by a factor of 10 every few hours. This extreme variation suggested the object had an unusually elongated, cigar-like or pancake-like shape. Scientists estimated its length could be up to 400 meters, while its width might be only about 40 meters. This roughly 10-to-1 length-to-width ratio made Oumuamua unlike any asteroid or comet previously observed in our solar system. Initial observations found no visible tail or coma, the cloud of gas and dust typically surrounding comets as they approach the Sun. This absence led astronomers to initially classify Oumuamua as an asteroid rather than a comet. However, careful analysis of its trajectory revealed a slight but measurable acceleration that could not be explained by gravity alone. This subtle but confirmed acceleration suggested Oumuamua might actually be releasing gas, behaving somewhat like a comet after all. Scientists proposed the gas causing this acceleration might have been invisible hydrogen, difficult to detect using standard telescopes. Other researchers suggested the acceleration could result from Oumuamua being unusually thin and lightweight, catching solar radiation like a sail. Harvard astronomer Avi Loeb controversially suggested the acceleration and unusual shape could indicate artificial origin. Loeb proposed Oumuamua might be a light sail, a thin artificial structure designed to be pushed by starlight or radiation pressure. This provocative hypothesis generated enormous public and media attention, though most astronomers remained highly skeptical. The vast majority of scientists favored natural explanations, citing insufficient evidence to support an artificial origin theory. Most researchers now believe Oumuamua was likely a fragment of a larger body, possibly a Pluto-like dwarf planet from another star system. One prominent theory suggests Oumuamua could be a fragment of nitrogen ice, similar to material found on Pluto's surface. Nitrogen ice fragments could explain both the unusual shape and the subtle acceleration through sublimation, gas escaping as ice evaporates. This theory suggests Oumuamua may have been ejected from a distant planetary system through a violent collision or gravitational disruption. Unfortunately, Oumuamua moved too quickly and was discovered too late for any spacecraft to reach and directly study it. This missed opportunity has motivated scientists to develop faster detection systems capable of identifying future interstellar visitors sooner. In 2019, astronomers detected a second confirmed interstellar object, a comet named Borisov, providing valuable comparison data. Unlike Oumuamua, Comet Borisov displayed a clear, visible tail, behaving much more like a typical comet from our own solar system. This comparison highlighted just how genuinely unusual Oumuamua's characteristics were compared to other interstellar visitors. Scientists estimate that interstellar objects like Oumuamua may pass through our solar system far more frequently than previously assumed. Most such objects likely go completely undetected due to their faintness and the limitations of current telescope technology. The Vera Rubin Observatory, beginning operations in the mid-2020s, is expected to dramatically increase detection of similar objects. This powerful new survey telescope could potentially discover dozens of interstellar objects over the coming decade. Future missions are being planned specifically to intercept and study interstellar objects detected early enough for spacecraft to reach them. Project Lyra, proposed by several scientists, outlines potential spacecraft designs capable of catching up to objects like Oumuamua. Such a mission would require extremely fast spacecraft, launched on short notice once a new interstellar object is detected. Oumuamua's brief visit fundamentally proved that objects from other star systems do occasionally pass directly through our own. This realization opened an entirely new field of astronomy dedicated to studying visitors from beyond our solar system. Whatever its true origin, Oumuamua reminded humanity that our solar system is not an isolated bubble, but connected to the wider galaxy. Material, and perhaps even now and then a fragment of another world, continuously drifts between the stars, occasionally passing near us. Oumuamua tumbled through our solar system for only a few brief weeks before vanishing back into the darkness between the stars, leaving behind more questions than answers, and a permanent reminder that we are not alone in an empty universe.